In this problem, you're given a set of output numbers and you need to find the input numbers. Now, in this example, it's a bit complicated. It's more of a silver or gold level response. So I'm going to do a simpler example first down here to show you what the process is. In this example, the pattern is that to get the output number, or the rule you need to use, is that you multiply the input number by 2. So this is multiplied by 2, this is multiplied by 2, and so on. In order to find the input number from the output number, you need to reverse the process. So the output in this case is going to equal to the input divided by 2. You're reversing that process. So to go backwards, you need to divide by 2. And that would give you 5 for this one, 6 and 7. If these were added by 2 each time, you'd have to subtract as your reverse process. For this example, the rule that we used was the input times by 5 subtract 7 is equal to output. So to reverse this process, we're working backwards, starting at the output and working backwards from there. So the rule for going backwards would be that the output is, and the last thing you do is subtract the 7. So if we're going backwards, you have to add 7 instead of subtracting it. That's your first step. So I'm going to put brackets around that because that's one step. Then what you did before subtracting the 7 was you multiplied it by 5. So you need to reverse that process as well. So you would have to also divide by 5. And this would get you to the input. So for this example here, we've got the output value as 8. So this machine has spat out an 8. We then need to reverse the rule back this way to find out what the input number originally was. What went into this thing to give us an 8. And we're using this formula over here, or the reverse of the original rule. So the output in this case is equal to 8. So that means it is going to be 8 plus 7, which is 15 divided by 5. 15 divided by 5 is equal to 3. So that's going to be the input value. So a 3 must have went into this for an 8 to be the output. Then for the next example, it's the same thing. The output in this case is 18, so it's going to be 18 plus 7, which is 25 divided by 5. 25 divided by 5 is 5. That would have been the input. So the input for 18 was 5. Then finally, if the output is 93, it would be 93 plus 7. That is divided by 5. And so the original input number must have been 20. And so it's a 20 for 93. Okay, so the key point is that in this is that you need to reverse the process. Whatever you did to get from your input to your output, you need to reverse that process.